So in Chapter 8, we're doing this now basically for two reasons. One, we learned how to do slope fields back in Calculus 2, and so it should be somewhat fresh on our mind. And second, we can oftentimes see what it is we're looking for, even if we don't know how to compute it. So let's see how we can create slope fields first off with the TI-89. So we're going to take this differential equation on the interval from 0 to 1 on x and 0 to 1 on y, and without trying to solve this, which we don't know how to do yet, we're going to see if we can visualize some solutions. And so let's take out our TI-89 and let's do this. We're going to first set the mode to differential equations mode. We do that by pressing the mode button where it says graph at the top. We hit the right arrow, select differential equations number 6, and then press enter to set the differential equations mode. Then we're going to use the y equals, just like we would with regular functions, to enter our differential equations. So we'll go to the y equals, out beside y1 prime, we're going to enter our differential equation. So the two things that you see here in red are simply saying the y variable has to be entered as y1 and x must be entered as t. My calculator only understands the variable t, as implied up here where it says t0 equals 0. And so here's our differential equations. We've got 1/2 times, and then parentheses. Now x squared is kind of normal, and when we enter y squared, sorry about that, x squared is not normal, that's t squared. Then when we enter the y squared, we have to enter it as y1 squared. So there's our differential equation. We will go to the window setting and set our window so that the x's go 0 to 1 and the y's go 0 to 1, and then draw the graph. So there's the slope field on my TI-89. Now while we're here, let's draw the slope field on Maple. Now I'm going to show you first off on this screen the commands as it's going to look, and then we will use Maple and actually type it in. So to do this, we need to load the DE Tools package. We will do this way because it makes handling and doing things a little bit easier. We'll define a variable to represent our differential equation, and then we'll just tell it to plot the differential equation. So basically 3 steps to use Maple to do the differential equation. So here's my Maple. We're going to select New Document. Now to load the DE Tools package, we type the word with, and then in parentheses we want DE Tools. So that's capital D, capital E, Tools. One of the things you'll get used to in working with Maple is that it is very picky about when to use uppercase, when to use lowercase. And for DE Tools, you use capital D, capital E, Tools, lowercase. Now, at the end of any statement, you have the option of putting a colon. In Maple, a colon at the end of a statement is to suppress output. Now, it doesn't prevent Maple from executing the statement. It just doesn't show all the details of the execution. I'm going to put a colon at the end. You can experiment with Maple and see what happens if you don't put a colon at the end. However, and I push enter, it just comes back to the next line. Now, what it did is load some new commands, some things that would not have been available had I not done this. So what we're going to do is we're going to define the variable. I like to use ODE to represent the ordinary differential equation. So we're going to say ODE colon equals. Now, colon equals is the assignment character in Maple. That just means we're going to be assigning what comes after this to the word ODE. And so we want to now enter our differential equation, the same one that we just did on the TI-89. Now, you'll notice over here on the left-hand side there are some tools that help us in entering things, one of which at the top under the calculus menu is the derivative. I'm going to click the derivative tool and complete the template. This is the derivative with respect to x. So I'm going to type the x. I'm going to scroll over. There's 1, 2, 3. I'm going to hit the delete key and type y parentheses x. So this is the derivative of y of x with respect to x. We're going to finish typing the equation. That's equal to 1/2. I'm just typing 1 divided by 2. Scroll out of the denominator, parentheses, x squared. Scroll out of the exponent, plus, now the variable, the dependent variable, as we've got it listed right over here, is y parentheses x. So we'll go y parentheses x squared. So we can't just type a y squared like we do when we write it. Maple has to have more specific information. It's y of x. So there's my differential equation. Now again, I could put a colon at the end of this, or I could leave it off. I'll show you what happens this time when I leave it off, because it's not as messy as the first one. If I just press enter without a colon, it simply parrots back what I just typed. Now comes the meat of the problem, and you could do this even if you didn't do that second thing, and that is to do the plot. Capital D, capital E, and then plot, lowercase, DE plot. The differential equation that we want to plot is what we just typed and named ODE. Now at this spot you could literally type the differential equation instead of defining it like we did up above. Comma, we have to specify the independent variable, the dependent variable, which we say y parentheses x, comma, and then we have to give it the range on the independent variable and the range on the dependent variable. So we'll say x equals 0, 1. The two dots side by side is our range character, comma, y 0, 1. And we're using y here because that's what it's going to show as on the graph. And so this is basically all we would have to draw a slope field. I press enter, and there's my slope field. Now I'm going to show you some of the options that are available. You can go to the help menu and see lots of other options available. We'll experiment with some of those later on in the course. So one of the options that I want to show you is how to adjust the color. I do not like red arrows. So I'm going to put my cursor right after the 1 in the DE plot, y0, 0, 1, 0, dot, dot, 1. I'm going to put a comma and then say color equals and pick a different color, like black. Now again, you can experiment with colors. You can go to the help menu, look up the colors, whatever. So here's the same graph but with black arrows. I also don't like the arrows looking like harpoons. I would rather they look like arrows. So I'm going to use the command, this is right after the word black, comma, arrows, that's plural, equals, and one of the options for arrows is medium. Again, this is something you can look up in the help tool. Here's medium arrows. Those look a little bit more like normal arrows rather than harpoons. Also, there's quite a lot of those going on here. So after the medium, comma, I'm going to put the option that controls how many arrows they actually put. That's called DIRFIELD, direction field. That kind of defines the size that I want the arrows to be. And so I'm going to put bracket and make this, say, I don't know, 15 by 15. So I'll have 15 arrows across, 15 arrows up and down, and again you see how that goes inside of brackets, and we get a little bit better view. So that's how we draw slope fields in Maple. Quick and easy. Here is another one that has initial values. So we're going to do the differential equation, dy dx equals x minus 1 over x plus 1 with the initial value y0 equals 8. So again, we're going to start off with our TI calculator. So on my TI calculator, I'm going to go to the y equals, clear out what I have beside y1. For x minus 1 over x plus 1, we're going to type parentheses t minus 1 and t plus 1. Enter. Out beside y1, we're going to type 8. That's our initial value. Let's change the window this time. We're going to graph this one on the window that starts at x equals, we can't quite go to -1, but we can go to -0.99. And we'll go up to 9. So we're basically going -1 to 9 on the x. And let's make the y's go from -1 to 15. So using that window, here's the graph. Slope field, initial condition. Let's do this on Maple. Again, one of the reasons that I did this the way I did this is we can simply come up here to the line that says ODE. We can modify our differential equation. Now I'll go to the fraction template and type the x minus 1 and x plus 1. Change my window. We want our x's to go from 0.99 to 9, and our y's to go from -1 to 15. So there's our slope field. Now, to put the initial condition in here, right after we have all of our options at the end here, we're going to put comma, and then in brackets we're going to put y parentheses 0 equals 8. That's how we specify our initial conditions. Here's the graph. I don't particularly like the yellow color, so I'm going to come back up here, comma, and tell it the line color is red. And so there's the same thing we got with our TI-89.